In October 2021, there was interesting news related to neurobiology, which is microglial cells as therapeutic agents in neurodegenerative diseases. So what is microglial cells? It is the innate immune cells of the central nervous system. Microglia enter the brain during embryogenesis and early postnatal development, where they shape neuronal maturation. Microglia contribute to CNS homeostasis throughout brain development by promoting neural precursor cell proliferation. In the mature CNS, microglia make up only 5% of the total glial population in the cerebral cortex. In general function, they serve as the first line of defense in the brain and protect the CNS from injury. They are also important for repairing damaged brain tissue and for clearing dead cell and molecular debris, such as incorrectly folded proteins. However, scientists have found that microglia can also damage neurodegenerative function. It is still unknown whether the microglia overreact until it becomes inflammatory to the CNS or the phagocytic activity declines. But if this happens, it could serve as secondary contributors to the pathogenesis, especially in neurodegenerative diseases.
It's true. Neurodegenerative diseases affect millions of people, including Malaysia. It happened when the nerve cell in the brain or the peripheral nervous system lost function over time and ultimately died. So what is Alzheimer's disease? It was first discovered in 1906 by Dr. Alzheimer, where he noticed changes in the brain tissue of a woman who had died of an unusual mental illness. AD also affects memory, thinking behavior, cognition, and the quality of daily life. The cause is still unknown, but the Amran-Casca hypothesis is the most widely discussed in scientific research today. Current Alzheimer's treatment. On 7 June 2021, FDA approved aducanumab as a new treatment for Alzheimer's. This medication is a human antibody that targets the beta amyloid protein and helps to reduce amyloid plaque. Other than that, scientists manipulate the microglia cells as the therapeutic treatment for Alzheimer's disease.
So, how do scientists manipulate the microglia cells as the therapeutic treatment for Alzheimer's disease? First, they modulating neuroinflammation, which means they push microglia cells in AD patients towards disease-associated states. One of the ways is by using cellular therapy with microglial stem cells to reduce amyloid beta toxicity, which can cause apoptosis to the neuronal cells in AD. By manipulating microglia cells, it can increase the clearance rate of amyloid beta deposits so that eventually neuroinflammation can be lowered. Second, they use antibody to activate innate immune receptor, which is TREM2. It is located on the surface of disease-associated microglial cells. This way can encourage surrounding microglia to the disease-associated state. And the third one, they produce drugs to manipulate activity of microglia by targeting at microglial cells, such as... However, there are some challenges. First, TREM2 can also be expressed by other macrophages other than microglia. It can affect systemic immune response, but so far, no data shows that agonizing TREM2 can lead to worsen the whole macrophage's function. Microglia also has complicated dynamic nature because scientists find that it has both activated and resting state, which can become pro-inflammatory or anti-inflammatory microglia. And it can be complicated because microglia also works together with other cells.
On one hand, microglia can act as an alternative to cure Alzheimer's disease. Early microglia accumulation may delay the progression of Alzheimer's disease by contributing to the clearance of beta amyloid, since they phagocyte beta amyloid and release enzymes responsible for beta amyloid degradation. There is a saying in Islam, with every sickness there is cure. Up until now, scientists are still researching the properties of microglia, and it is possible that as a result, more researchers will develop treatments or medications that target these cells in order to cure Alzheimer's disease. To conclude, the impacts of microglia on Alzheimer's disease appear to have a dual component. On one hand, their activation seems to be neuroprotective at early stages of the disease, but the effects may be counterproductive at older age. Therefore, there is a need to investigate the changes in phenotype of microglia and how they react to anti-inflammatory therapy of age. And we hope that in the future we are able to cure Alzheimer's disease with optimal efficiency but minimal unwanted modulation of microglial phenotypes.